So in this video, we're going to start talking about the third type of system of equations, and that is elimination. So this is part one. Let's do some definitions. First is the coefficient, which is the numerical factor in the term. You should already know that. Also, the additive inverse, which is just the opposite of something. Also something you should already know. Now, elimination is the act of removing or getting rid of something. That is something new mathematically to you. So, elimination. All right. Very important concept number one. When the coefficient of the x or the y term are additive inverses, you can solve the system by adding the equations. And the key word here are adding is if the x or the y term are additive inverses, you can solve the system by adding. Okay? And an addendum to that, if one of the variables has the same coefficient in both equations, then you want to subtract. So what does this mean? Well, so let's find our solution to our equation. So we have x minus 3y equals 7, and then 3x plus 3y equals 9. So the y terms in this case are additive inverses, because if you look, we have negative 3y, and then we have positive 3y, so that makes them additive inverses. So in this case, we're going to add the equations, because that's what the Vic number one said. So I'm going to line them up like this, because in the situation of systems, lining them up vertically is much easier. So we have x minus 3y equals 7 plus 3x plus 3y equals 9. So when you're trying to use elimination, your goal is to eliminate one or other of your variables. So in this case, we're going to eliminate the y's. So we have x plus 3x, and remember this is the same as having this imaginary 1. So 1x plus 3x gives us 4x, negative 3y plus 3y gives you 0. So we have eliminated the y's, and that was our goal. Now 7 plus 9 gives you 16. So that leaves us with 4x equals 16. If we divide both sides by 4, we get 4. Okay, so that tells us that x equals 4. But remember, systems of equations, you need an ordered pair. So if we know x, how do we find y? We plug it back in. Either equation, but not both. I'm choosing the easier one. Plug in my 4 for my x. So now I have 4 minus 3y equals 7. How do I solve it? Well, my 4 is positive, so I subtract 4 from both sides. 4 minus 4 gives me 0 on this side. 7 minus 4 gives me 3 on this side. Divide that negative 3 away from the y. I get y equals negative 1. So what is my solution? Oops, it's not exactly a box. But my solution is 4, negative 1. So I know that if I graph both of these equations, they're going to touch at 4, negative 1. Okay, so that's what happens when your y terms, or it could have been x terms, in this case the y terms were additive inverses, and I was able to add my equations. So what happens if they're not additive inverses? This time we have x plus y equals 18, and x plus 2y equals 25. So this time, notice the x terms have the same coefficient. What is that coefficient? 1. So we're going to subtract the equations. Okay, they're both positive, so I'm just going to subtract. So again, line it up vertically. X plus y equals 18 minus x plus 2y equals 25. What happens when I do this minus? It makes everything in here negative. And then I can make it plus. So now I'm rewriting it. Rewriting it as a plus, but notice everything has become negative. So now I can cancel like I did before. This time my x's will eliminate, and I can work with my y's. Positive y minus 2y gives me negative y, or negative 1y if you need it, equals negative 7. Well, negative y equals negative 7. I can't have a negative y, so what do I have to do? I divide each side by 1, by negative 1, so that I get y equals 7. Well, again, I have to find out what does x equal. So I can plug it back into either equation, plug it back into this one. So x plus 7 equals 18. I just took my y value and plugged it in. Subtract 7 from each side, I find out that x equals 11. So my solution, or the point where my two equations would cross, is going to be 11, 7. Okay, so let's review, and you saw this in the last video as well, the 3 types of solutions. If you had a graph of intersecting lines, you're going to get an equation. Whoops, this should say y. Just like we just got in that last one. X equals 7, y, or x equals 11, y equals 7. There's one solution because they touch at one point. Okay, if it's the same line, and you get, if you were to graph them, you'd get 2 on top of each other. Your equation would come out something like 10 equals 10. There's infinitely many solutions, or all solutions will work. If they are parallel lines, your equation is going to come out to be something like 17 equals -4, where it's never going to work out. You know, when we're solving equations, we call this no solution. So again, there's none. There's no solution because they're parallel. They're never going to touch. And so when we're solving a system of equations, this is what we're looking for. Are they going to touch at one point? Are they laying on top of each other? Or will they never touch because they're parallel? And that's part 1 of elimination.